Let me introduce myself first. My name is Ashley Tarver with Cloudera, and I've been asked to be a guest speaker on this event. We also have Mike McDonald from Quanta Networks, and Drew Rubin is on board from Spotinst as well. So today, we'd like to take you through some ideas on how to reduce cloud cost. More specifically, in my personal experience, this technology has done a really good job at helping my customers find new budget. And this new budget's been able to get reinvested and into other projects related to big data and analytics. So today, what we'll do is go through some of the aspects of how that's worked in the past, and then provide you some details on how you can implement the same technologies for yourself as well as your own customers. So the agenda is very simple. We've got a short introduction as to who Quanta Networks is. I've got some slides that talk about how I've been able to open up new budgets for key projects. Then we'll introduce Spotinst, which is the technology that is the focus of today's conversation. And Drew will be in a position to give us a demo on how the technology works. So if you have any questions, feel free to raise your hands. Mike, I'm sure, will be following up on that and helping us make sure we answer your questions. We'll also have a Q&A at the end of the demo, so feel free to wait till then as well. And we'll get started. I have the pleasure of working with Quanta Networks in a lot of spaces. They happen to be a partner of Cloudera's. They're also a Cisco partner who I work with very closely, and as well as Spotinst, which is our technology partner on today's call. Quanta Networks focuses as a systems integrator in the area of data and analytics, and they have an end-to-end solution set that allows to help companies along their entire data journey, whether it's developing a strategy and planning design for the company, or moving into a data lake, creating analytics, or bringing in machine learning and artificial intelligence. They've got the capabilities and the technology to help companies on that journey. Their focus is primarily in use cases. So what they do is work with customers. There's a handful of use cases here, from database savings to predictive maintenance, customer churn, you name it. What they like to do is work with their customers to identify the use cases and then develop solutions and technologies that can be used to apply to that. So in today's conversation, the focus is around cloud migration and cloud savings. Quanta has the ability to help customers along this journey, from doing cloud assessments and strategy planning all the way through the data migration of the actual applications that are being migrated from a premise solution into the cloud. But today, we're going to really focus on the last two buttons, which are leveraging the cloud and optimizing the cloud. And the way this is done, the technology partner that we use in this regard is Spotinst, and they've got a solution that we'll talk about shortly that allows you to take advantage of AWS Spot instances in a way that allows you to save huge amounts of money off your normal cloud spend, whether it's on demand or reserve instances. And let me tell you how I've done this with some of my customers. I've got two use cases I'll share with you, which prompted me to want to be a speaker on today's call. I've got one use case where I'm working with a manufacturing customer, and they're wanting to implement a predictive maintenance solution across their manufacturing line. So as raw materials are ingested into the manufacturing process, and during the manufacturing process, and after shipment and QA checking is done, they wanted to be able to put analytics on top of that in order to create a predictive maintenance solution to lower operational costs, improve yield rates, improve quality checks, and ultimately bring better products to the market for their customers. The problem was the amount of budget they had available wasn't sufficient enough to actually execute on that project. So we've been talking to them about migrating their cloud workloads to Spotinst. With that ability, you'll see shortly how Spotinst has the ability to take your existing EC2 workloads, whether this particular customer is looking at on-demand and reserve instances, we have the ability to actually migrate those into spot instances, which obviously creates a huge cost savings. That cost savings is allowing us to actually execute faster on this project. So we're estimating that this particular customer will be able to accelerate their project by as much as 7 months, which would allow that customer to be able to recognize the predictive maintenance savings much more quickly. And by combining their cloud strategy with their predictive maintenance project, we've been able to really accelerate the work that's going to be done to accomplish the predictive maintenance use case. Similarly, we got another customer that's focused on what I would call a customer 360 project. They're pulling in data from multiple resources within the company, their ERP system, their CRM systems, their different business processes are being consolidated into a single data lake on top of Cloudera. So Cloudera is acting as the actual data lake for all the data, whether it's structured, unstructured, semi-structured data, and it's allowing the data scientists to take a deeper look to build a customer 360 solution that allows them to increase their overall customer satisfaction, give them greater insight on what their customers are buying, what they're trending with, and as a result, they're able to use that information, create some machine learning analytics on top of it, and they're going to be able to better allocate their sales resources, their support resources, and their product resources to help customers see a better solution with the products that they manufacture. Same model here. With the help of Spotinst, we're combining the cloud strategy they have with this particular customer 360 project. And just as in the last use case, by migrating existing on-demand and reserve instances over to Spotinst, it gives them the ability to free up additional money that they're able to reinvest back into this customer 360 project. So the idea is to provide an open door for additional budget that they might not otherwise have. In this example, we're seeing a potential for about $100,000 in cloud savings, which will be reinvested into the actual customer 360 project. So that's the type of work that we're doing together as a part of this seminar. You've got Quanta coming in as a systems integrator, Cloudera as the big data lake, and Spotinst as the cloud tool to help save money. And so with that, what I'd like to do, Drew, if you can step in, I'd love for you to make an introduction and talk a little bit about what you're going to be talking about today.
Yeah, thank you, Ashley. This is Drew Reburn. I'm a senior account executive at Spotinst, and I work with our enterprise customers in the Western United States. So I want to take a bit and just talk about what Spotinst is as a company and how in particular we help people achieve those results with respect to cost savings with no compromise on uptime. And so I'm going to share my screen very quickly. Let me know. Can you actually see my screen now?
Yes. Go ahead and put it in presentation mode and you'll be great.
Should be perfect there, right?
Yep, we see you.
Wonderful. Okay. Well, Spotinst is actually a 4-year-old startup founded in Tel Aviv in Israel, although our United States headquarters is here in San Francisco where I sit. And so we've raised about $60 million in venture capital funding so far. And we actually have over 150 employees globally and more than 1,500 customers worldwide. And so I think what it speaks to is the fact that what we built with respect to automation and cost savings has been immediately valuable to a wide variety of customers. And that's people like, you can see Ticketmaster on here, Intel, IBM, Sony, and some other major names in the industry who are running major enterprise workloads. What we've built is really valuable for them. So I'm going to take a moment and talk through what that is. Ashley alluded to spot instances, which are offered by Amazon earlier, and how it's a good thing to get workloads on EC2 from on-demand onto spot. When you're buying EC2 on-demand on Amazon, you're paying the standard hourly rate or per minute rate or per second rate, whatever it is, and that instance is always available for you. If you reserve the instances, you're committing to pay a certain amount of money for a 1-year or 3-year term to always have the instance running. and you might get something like a 30 to 60% discount on that. Spot instances are the least expensive way to pay for EC2. And what spot instances are is Amazon's always building out new data centers and new infrastructure. And so as a result, they have a lot of servers sitting idle. They offer those idle servers at a drastically discounted rate because they'll still make a little bit of money on it, just as long as they're making more than the cost of power. And they'll offer it at a drastically discounted rate. But the problem is that if they need that infrastructure to do anything else, they will take it away with just 2 minutes notice. So you can't traditionally rely on spot instances for highly available applications. That's the problem that Spotinst as a company has solved. What we've built is a prediction algorithm that anticipates those interruptions 20 minutes in advance. And when we do, we will either gracefully replace the interrupted instances with spot instances elsewhere in the VPC in order to keep costs low, or we will fall back to on-demand. As a result, we're able to offer a 99.99% uptime SLA on the drastically cheaper spot instances, often an 80 or 90% discount, sometimes a 70% discount. So we're able to offer a 99.99% uptime SLA on that with no compromise on the availability of your applications. And so this is the least expensive way to pay for EC2. There are a few different use cases that make sense for what we do in a really natural way. And we can work with almost every kind of workload out there, but I want to call just a few of them out here. One is any kind of containerization framework. So especially when we think about Kubernetes, we think about ECS, which is Amazon's flavor of this. We do extremely well with this because we've built our own autoscaler that actually helps you deploy onto those cheaper spot instances. We're able to listen to the compute requirements of the containers themselves. And that way, when we only spin up the spot instances necessary to actually run them, and we play the Tetris game with a variety of different instance types and sizes to make sure that we're fitting the pods in and utilizing each instance to a high degree. And so you win in two big ways from the perspective of cost with no compromise on availability when you use our containerization frameworks. One is that it's all running on Spot anyway. And so you're already cutting your EC2 cost by something like 70, 80, 90%. Number two, all of these containers are utilizing the instances at a really high rate, something like 90 to 95%. And if you just try to scale a containerized environment based on the underlying metrics from the EC2 instances themselves, like compute utilization or memory utilization, then you might end up with something like 60% utilization of your instances compared to the 90 or 95% with us. What ends up happening is that you run the same environment and have the same uptime delivered for your customers, and you need 30% less EC2 to do it. So not only do you need 30% less EC2, but the EC2 you're using is already running on Spot anyway. Another thing we do extremely well is auto-scaling applications. So if you're using auto-scaling groups on Amazon today, then it's really simple to actually make the move to Spotinst. Everything that we do takes place in your own Amazon account or your own Google account or your own Microsoft Azure account. And we're able to do work inside of your account using a cross-account IAM role. So that way we have some permissions that are pretty limited to spin up infrastructure and take it down. And anything that you've already got configured as an auto-scaling group is a pretty natural fit for our platform for the following reason. What we've built is basically a replacement in an AWS architecture diagram for an auto-scaling group. So we have what we call an Elastic group, which actually is our own cluster management software that spins everything up and runs it on Spot instances and handles the make sure it's linked to your VPCs and security groups and things like that. So as a result, anything already in an auto-scaling group can get moved over to our platform very easily with no downtime to your customers. I think the last use case that we do extremely well is one where our customers have always told us that if they're already using reserved instances, since they're committed to pay for them, they don't want to make the move initially to Spot instances because a new Spot instance is actually going to be more expensive than an existing reserved instance since they already have to pay for the reserved instance. What we're able to do there is our platform can actually detect your vacant reserved instances, and we will first spin up on-demand instances that match the vacant reserved instances. So if you had some M4 reservations for that instance family, we would first spin up on-demand instances in the M4 family. So that way we soaked that up and got you to 100% RI utilization. As time goes on and those RIs expire, we will actually make the graceful replacement whenever they do of that on-demand instance with a Spot instance. because now a spot instance that is new is less expensive than buying a new reserved instance. So in that way, we're able to help our customers transition over to using spot instances on all of their applications. About that. And I think at this stage, what I'd like to do is proceed just to a demo, because we talked about some of these things already. And so I'm going to switch my window here and show you what the Spotinst console actually looks like. So anybody who logs in and links an account with us is going to see this console. And as you can see, it'll show you how many spot instances that you're running, hours. Potential costs is when we measure all of the EC2 that you used in our platform, and we show you what it would have cost at the on-demand rate. The actual spot cost is what you ended up paying Amazon, and then we derive the savings percentage and the total saved from those two numbers. One of the important things I think to call out about our business model and the way that we actually charge a fee is that it is based as a percentage of savings. So anybody who signs up on the website would pay Spotinst 20% of savings. And so what you would end up seeing is something like this. Potential cost for 66,000, actual spot cost for 22. We would take a 20% cut of the $44,000 here. And so that would be something like just over $8,000, something like $8,800. And so if you take that and add $8,000, let's say this ends up being $31,000, you've cut the cost of EC2 by more than 50% on a net basis with no actual commitment to running it even for another month. You can turn all this off in any given hour. And so for that reason, Spot's a really powerful way to run EC2 at a really low price. I'm going to walk through the actual Elastic group and show you what one of these looks like under the covers. If you look on a per cluster basis, we're able to show you some of the same metrics with respect to the number of instances, potential cost, actual cost, and savings percentage. If we actually take a look at this, and I'm going to walk through what a setup of a cluster might look like when I go here. If I go to the edit configuration area, I start up here in the general tab, and first I would name it and I would choose the region for this cluster. You can see we have Terraform integrations that we'll be able to talk about a little bit later. And then when it comes to capacity, what I'm able to do is express this as either the number of instances or the number of vCPUs. And then the target is what we're going to try to keep the cluster as close to as possible. Minimum is what we will never go below, and maximum is what we will never go above. And so this is how you actually set the size and total compute of your cluster. If I enter into advanced configurations and I look at cluster orientation, no matter what you choose here, our 99.99% uptime SLA is going to be in effect. So all these are going to be highly available clusters, but we're going to make some different decisions with our algorithms based on what you choose. If you choose cost, and let's say we're successfully running an M42XL in US East 1B in that availability zone, and we notice that M42XLs in US East 1C are now less expensive, we will actually make that graceful replacement even though we don't detect an interruption upcoming for that instance that's successfully running. This is because we're orienting the cluster to make sure that it's constantly turning over different parts of itself in order to capture the lowest possible cost based on the fluctuating market prices of the spot instance marketplace. If instead we choose availability, when we notice something like that, we will actually ignore it and let the cluster continue to run as is. This can be really useful if we're running a stateful application like MongoDB or Cassandra or something like that, and I'll talk in a bit about how we can actually accomplish that. But in those cases, you wouldn't want to be constantly turning over the different nodes of the cluster without planning them in advance. There are often occasions where you would want to run a certain number of on-demand instances in the cluster with the rest of your spot instances, and you can do that here in one of two ways. One, you can express it as a percentage and say, okay, I want 50% of this cluster to be on-demand and 50% to be spot. Another might be to say that I just want a minimum number of on-demand instances that are always going to be there. A really good use case for this would be something like MongoDB, where you want a certain number of instances to never really turn over so that they can just be there for replica purposes. We talked earlier about how we use reserved instances and help you transition. If you check this box, we will actually spin up on-demand instances that match the parameters you set for this cluster to make sure that we're soaking up your reserved instances and getting you to 100% utilization. And then fallback to on demand is the box that you would check to make sure that in the event of us not being able to find any spot capacity, we will fall back to on demand and make sure that we provision on demand instances, which should always be there. And then with respect to maintenance window, if we do fall back to on demand, then you can set the maintenance window for when we roll you back onto spot. I mentioned earlier that capacity unit can be expressed either as instance or as vCPU. And then if we do detect an interruption for an instance and we want to take it out of the pool and replace it with something else, then you're able to set a custom draining time out here. Because what we'll do if we detect an interruption for an instance is stop sending it new connections in a load balance pool, but we'll let it resolve its existing connections for however long you set the draining time out here. So for some applications, it might be appropriate to set a 5-minute draining timeout. Others, you might just want 2 minutes. All depends. The last thing that I would call out on this tab would be that if you want to actually schedule a scaling event in advance, you can do that here. So let's say we want to do any one of these things, like, for example, give a new capacity range at a certain time and change the target capacity. We would express that here and then write the actual time that we wanted that change to take place. Many of our customers will use a tool like this in order to, if they're running test and dev servers and they want to shut them down overnight and not pay for anything at all and shut them down over the weekend, this might be a great place for them to do that. When I take a look at this compute tab, I think this one is really the meat and potatoes of everything that we do. And it kind of talks in a lot of depth about how our platform really works. So when it comes to the VPC, you just select the VPC, you select the OS, and then whether we're provisioning on-demand instances as just a part of or percentage of your cluster, or we're falling back to on-demand, you can choose the on-demand type that we're going to use, since they should always be available. And then you let us know which availability zones and which subnets you want us to use as well. Now, I'm going to come back to the spot market scoring map because I think it often makes sense to show the spot types here first. At the top, you can see the different instance families. All of those are written up here. On the left, you can see the different instance sizes. So for example, if we want to add some instances from the R5 family to this cluster, we might check those boxes, and we can add the C5 family as well. You might be able to see that we actually were able to add more instances to this heat map as a result. Let's say we add another availability zone. We can still add more instances to this heat map. Each one of these represents a completely separate spot market. And so C44XLs and US East 1D are a unique spot market whose availability is not linked with any of these other spot markets. We give them each a score of 0 to 100 to help determine where we want to deploy infrastructure on your behalf. And so we might say that this one has a score of 90, and there might be a few factors implied in that score. One is going to be just generally how low is the price compared to the on-demand rate. A lower price will get you a higher score and make it more likely for us to deploy there. Another factor is going to be the longevity. Was it last interrupted 4 days ago, or was it last interrupted 45 days ago? It might surprise a lot of people, and it certainly surprised me after I joined Spotinst, because I'd worked at Amazon Web Services for 4 years before that. It surprised me that a lot of the spot instances actually will run for something like 30 to 40 days straight, rather than just running for 4 hours or 5 hours or something like that, which was often my impression. So the interruptions might happen less often if we make good decisions here. We will also keep track of the volatility. If we're noticing that some instances for some of our other customers are getting interrupted, then we might actually ban a spot market outright, which it looks like we've done here. If we have one here that's in the red, we're just generally not going to deploy anything in that spot market, and we're going to wait for things to get a little bit more stable there. And so we'll move all of our customers out. One of the nice things that we've got is that this is actually a map of what all of our customers are experiencing globally. One of the things that helps us as a platform is that on behalf of our over 1,500 customers, we're running hundreds of thousands of spot instances on Amazon at any given time. And so if we are experiencing any interruptions or any instability for one of our customers, we're able to take that information and use that to help make algorithmic decisions for all of our customers to ensure that we're deploying people in the markets with the most availability. It's these things combined with our 20-minute prediction algorithm that enable us to have that 99.99% uptime SLA for our customers to help them capture the great savings that come with Spot. Now, as I move down, and I look at launch specification, you will notice a lot of these things from the Amazon console. We will launch your AMI, and we will launch them in your security groups, and your key pairs and tags will still be persistent, and you can still modify them here. The only thing I would really want to call out with additional configurations is that if you want to give us a bias towards deploying in a certain availability zone, or give us a bias towards deploying with certain instance types, you're able to give that to us here. If you did this, for example, we would be more likely to deploy C4 4XLs and C4 8XLs in this cluster. But that doesn't mean we will exclusively deploy there. We will still make sure that we're distributing the cluster among a variety of other nodes, but it'll just give us a main bias to make sure that if you have an instance type that is really finely tuned for your application, you can take advantage of that here. Here you would put your user data, and then if you want us to run a shutdown script every time we terminate an instance, you're able to just put that in here. Now, when it comes to stateful applications, things like MongoDB, Elasticsearch, Cassandra, and all of that, most people don't really run those on Spot because the Spot instances might get interrupted, and a stateful application can tolerate a little bit of interruption of some nodes in its cluster, but you want to be cautious about something like that. We're actually able to still offer our same SLA on stateful applications and help customers drastically cut costs on some of those applications that I just named in the following fashion. If you click these buttons, we will persist the root volume and the data volume, and we'll maintain a private IP. What this means is that we will take incremental snapshots of both the EC2 instance and the EBS volume supporting it every few minutes. We're only going to save 3 incremental snapshots at any given time, so you don't have to worry about having all of a sudden terabytes of data sitting in S3, but we will just save those. And then if we do detect an interruption for one of the instances in that group, we will go ahead and shut that down and then take one final snapshot of the instance and the EBS volume, and then use those snapshots to reboot the instance and EBS volume somewhere else in the same VPC. Because we're maintaining the private IP, all that your cluster is going to see is that one of the nodes disappeared from the cluster for a little bit and then came back with the same private IP and all the same data saved on it. And so as a result, there won't be any interruption to your end customers or anything like that. This is a simple portion. You just can choose a load balancer here in order to register S2. And then down here, I talked some about the container integrations that we've got. We have a wide variety of other software integrations. If any of these look like things that you have and that you'd like to hear about from us, certainly be appropriate to contact us after this webinar, and we can discuss the individual ways that we work with any of these software packages. When it comes to scaling, because we're running the cluster that's a replacement for an auto-scaling group, we still need to have auto-scaling capabilities in the event that we're running app servers or a stateless web application or something like that. And so you can set the same simple scaling and target scaling policies here that you would set on Amazon Web Services. So that won't be different at all. And then lastly, when you get to the summary, you can see a plain English summary of everything that you just configured in this cluster. And then you can get the JSON here if you just like to interact with the API. And then we also pre-build CloudFormation and Terraform templates for you as well. So for Terraform, for example, we're an official Terraform provider, and all you would do is just put this into the same console, and it will successfully spin up Elastic groups, which is our cluster, in order to do everything that you would normally do through Terraform. And so you can configure everything that I just showed you here, all in this same template. So we have a lot of customers deploying through CloudFormation or Terraform today. I think the last thing that I want to talk about altogether would be that if you did link an account with us, a lot of our customers want to discuss exactly how they can evaluate how much money they can save on Spot instances, given their current workloads on Amazon. What we have here is the Spot Analyzer, and what it looks at is all of the auto-scaling groups and target scaling groups that you've currently got deployed. It takes a look at all of the instances that you're running in those groups, and it matches that with the current market price of Spot instances in order to show you the potential savings off on demand that are available out there for you. So if we look at this group, we can see potential monthly savings of $585 based on the current prices. And then if we actually want to migrate it, all we do is press clone here and then match the region in the auto-scaling group. And then we just press next. and it takes us to the final page that we have, where you can actually get the same CloudFormation template or Terraform template if you'd like, and look at the plain English summary of this Elastic group that we're about to spin up. When we spin it up, once it brings up its instances and the health checks are all green, you should be able to actually take down the auto-scaling group that you had before, and there will be no interruption to any of your end users because all of the traffic is now going to be distributed to EC2 instances being run by our Elastic group.
Okay, Drew, thanks for your time as well. It was good working with you. And everybody on the call, thanks for taking out some time with us today. We look forward to following up with you.
Thank you, everybody.
Have a great day. Bye.